Okay, so continuing with fault management. So the objective of today's lecture is to understand the steps of fault management. We had started with the first step. So we will be continuing with the remaining steps. And then as a part of fault management, we will be studying event correlation techniques. Okay, so the learning objective or the learning outcome from the above objective will be you will learn about the exact procedures to be followed in the fault management. See, they will not teach you कि ये fault हुआ है तो you will do this and this. Okay, the procedures that you can follow, the probable procedures. So that there are certain steps which we had seen. So you will learn that one and how event correlation will help in the fault management. Okay, so when I talk about fault management, an important aspect is event correlation. So that two of them we will try to finish. There are 6 event correlation techniques that are mentioned in your book of money. So we will try to finish 2 today and then the remaining 4 in the next lecture. Okay, so we were at step 2, fault location or fault isolation. So once I know, first step was fault detection. Okay, so once I know that fault has occurred, I need to know where the fault has occurred. Okay, I have to zero down the fault. Okay, so what should be my approach? Okay, so there should not be very sophisticated approach. Okay, so what they are saying is fault location using a simple approach would be to detect all the network components that have failed. So the very first thing when the fault occurs and I'm trying to find out where the fault is, so the thing that comes is might be some network component is not working. Okay, so the origin of the problem could be then traced by walking down the topology tree where the problem starts. Please don't imagine that you will walk down the network, means actual physical walking. It is not possible because the network is laid down in a very wide area. You have seen different types, LAN, WAN, MAN. Okay, so the network is not small. Walking down means slowly from one point of contact to multiple contacts. So that we have the topology tree. So from one level, you will move down, or from down, you will move up to the top level. Okay, so that is what is meant by walking down the topology tree where the problem starts. Suppose if an interface card on a router has failed. Okay, this is just some examples they have given. So all the managed components connected to that interface would indicate a failure. Okay, so then from, see, all the components would indicate a failure. So whether now I have to find out कि वो सारे components में fault है, कि interface card में है, या router के कोई और part में है. Okay, so this is how you are walking down the topology tree. So after having located where the fault is, okay, so now you have found out कि ठीक है, कोई तो interface card में वो fault है. So the next step will be to isolate the fault. Isolate means exactly find out कि कहाँ पे fault है. Okay, तो zero down हो गया. First, we should delineate the problem between failure of component and the physical link. Example, the interface card may be functioning well, but the link may be down. So this is what we are meaning by isolation. कि ये patch में problem है, but कौन से exact source से problem आ रहा है? So that is what we need to do. So what we have to do, we have to use various diagnostic tools to isolate the cause. If you remember when we started with our first module, okay, we had the case study, case of footprint. Okay, so the vice president there, he used his thinking power. He saw the footprint of the sneaker on the table and then he found out where the fault was. So means the conclusion from that case study was you have to use all your diagnostic tools, whichever way it is possible, to find out where the fault is and isolate the fault. Okay, so suppose continuing with the fault management, suppose that the link, we said no कि link में problem है या router में है या switch में है. So suppose for the moment the link is not the problem. तो फिर problem कहाँ पे है? These are some discussions which are given to show how you will find out ये, if not this, then might be this, there is a problem in the other thing. So suppose there is the link is all okay. So then the interface card might be faulty. So then we proceed to isolate that interface card. Now interface card, we have many layers. So then we will find out कि कौन से exact layer में fault है. Suppose that excessive packet loss is causing a disconnection. तो अगर मुझे ये aspect check करना है, so what I will do is I will measure the packet loss by pinging. So here I can use ping command also to check whether that host is reachable or not. So we can query the various management information based parameters on the node itself or other nodes to further localize the cause of the problem. So we are trying from all aspects to find out where the fault is. Suppose, for example, the error rates calculated from the interface group parameter with respect to an output packet rates could help us isolate the problem in the interface card. Okay. अगर मुझे पता करना है कि इंटरफेस कार्ड में प्रॉब्लम है, so I can calculate the error rate. So all these things I can easily solve if I have an artificial intelligence solution. So the preferred way also is I can have an artificial intelligence system which will take up all the symptoms that are present and it will try to find out where exactly the fault is. So by observing all the symptoms, we might be able to identify the source of the problem. There are several techniques to accomplish this. Okay, so you can study more about how using artificial intelligence, we can solve that particular problem. So this is just, they have given that using artificial intelligence, you can solve a particular problem. The next point is using event correlation. Now here they had said is, by observing all the symptoms, we might be able to identify the source of the problem. So there are several techniques. So one of the technique is event correlation technique. Now let us understand. So you can explain event correlation along with whenever you are, suppose a short note on fault management is asked, or event correlation can be a separate topic. Now event, and then we are correlating the event. So what is an event? We will understand the event word I have used earlier also, but I don't know whether you remember it or not. So if this is called as an event, okay. And then some event has occurred or will occur in future, and I'm trying to correlate those events. Okay, last time department day ऐसा हुआ था, ये चीजें होनी चाहिए थी, नहीं हुई. Okay. So one event has occurred. इस साल डिपार्टमेंट डे में हम लोग ये चीजें करेंगे, ये इम्प्रूवमेंट करेंगे. So we are trying to correlate something which has happened in the past. One event has happened in the past. Now here when I talk about event, it is all related to your network functioning. Basically the faults or the traps or the alarms or the notification, every management uses a different words. Okay, so some alarms had occurred, some trap messages were there, which were indicating a problem in the network. So I'll try, if something has happened now, I will try to correlate, अच्छा तभी ये problem हुआ था और ये solution था. Okay, so that is what in simple word I can say event correlation. Okay, so when a centralized NMS receives a trap or a notification, we say that it is receiving an event. Okay, so an event means a trap, alarm or notification has occurred and it is receiving an event. Now a single problem has occurred in the network, but it may have multiple symptoms, and each symptoms detected is reported as an independent event to the event management system. Okay, so suppose a single problem has occurred. One of you make noise, but there are multiple symptoms. Okay, what multiple symptoms? The video lecture is not getting recorded properly. The teacher gets angry. The teacher does not give you attendance. The teacher gives an extra assignment to be solved. Okay, so problem एक बच्चे ने किया बदमाशी करके लेक्चर में, but there are multiple symptoms. Okay, now each symptom is detected, is reported as an independent event to the management system. So if all these things are reported to the class teacher, तो class teacher को तो यही लगेगा कि B NMT में एक extra assignment मिला, okay, ये self study मिला, attendance nahi mila. So that is what is an independent event, but the problem was only that one child who played a prank in the class. This is just an example I am giving. Now, obviously, we do not want to treat each event independently and act to resolve it. अभी देखो, जब NMS को report हुआ तब multiple symptoms था, but the cause was only one. Okay, so if we now try to treat each event independently, कितना काम बढ़ जाएगा, जबकि source एक ही था. So what we will try to do is, then the class teacher, what the class teacher will do is, she will try to correlate. अच्छा ये बच्चे के वजह से ये ऐसा हुआ, यही बच्चे के वजह से वापस दूसरे दिन ऐसा हुआ, यही बच्चे की वजह से तीसरे दिन ऐसा हुआ. So instead of treating all things separately, okay, what the teacher will do, he will catch hold of that single student who played all that prank and try to find out the root cause of the problem. So what we are trying to do, the management system correlates all the events and it isolates the root cause of the problem. So the technique used for accomplishing this are called event correlation techniques. I hope you understood what I am trying to say by this particular slide. So there are several correlation techniques that are used to isolate and localize faults in the network. So all are based on detecting and filtering of events. Okay, there might be many events that has occurred. Okay, suppose I have a particular problem. All the previous events, I need not go through kya kiya tha un logon ne. I will check the relevant event which is having more meaning or which will give me a particular solution. मुझे सारे events देखने की जरूरत नहीं है. Okay, so I should be able to filter out also some events. Then correlating observed event to isolate and localize the fault either topologically or functionally, and then identifying the cause of the problem. So my final goal is, whatever I try to do, I filter out event, I detect event, I correlate. Okay, I need to find out the cause of the particular problem. So there are various approaches for event correlation technique. So 6 approaches are there. One is rule-based reasoning, second one is model-based reasoning, case-based reasoning, code book, straight transition graph model, finite state machine model. Please don't think कि ये सब theory में रह के ही है. Okay, you might not have utility right now, but we know that networks exist, management of network also is there, and there are problems which the manager needs to solve. How to solve that problem? See, the problem is not just I'm replacing a switch, replacing a link. There might be some problems which happen again and again. Why we go for advanced technology? Because we feel कि हाँ more users है. If customer demands more kinds of services, the current technology is not able to support that. Okay, so that is also one of the problem. Okay, so I need to know कि हाँ ठीक है. Then I need to study कि वो वाले मेरे competitor company ने भी ये चीजें किया था. So all these I will try to name some companies also when I am giving you all these description कि this particular company, तुम लोगों को लगेगा अरे ये क्या है, ऐसा reasoning है, directly start searching the fault and all. No, that is not possible when I'm having a very big networks and there are interconnections between multiple networks. Okay, so I need some way to manage the fault by studying the behavior of the network in the past and the current behavior of the network. So all these models are used somewhere or the other in big global companies for their fault management. So starting with rule-based reasoning, from the name rule. Okay, so some rules are made. Okay, so if some rules are disobeyed means the fault is there. So rule-based reasoning, we call it as RBR also. It is the earliest form of correlation technique. So rule-based reasoning is also called as rule-based expert system, production system, or sometimes blackboard system. So ये बहुत पहले आया था. So they had all these different names. Now, what are the components in a rule-based reasoning is, उसके पास एक knowledge base है, एक वर्किंग मेमोरी है और एक इन्फरेंस इंजन है. सो three components are there in a rule based reasoning model. So at three levels, so we have a knowledge level, a data level, and a control level. Okay, so knowledge based, working memory, and inference, ये तीन components से ये तीन levels है. So I'll show you the diagram of a rule based reasoning. So there is a rule which is followed. If something has happened, then something will be done. So that is a rule. If XYZ thing has happened, then ABCD is the solution. If PQRS has happened, then WRST is the solution. So there is a rule which is maintained. Okay, and if some problem has occurred, then I check that कि क्या है, अगर ऐसा ऐसा हुआ तो मुझे ऐसा 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 करना है. So a rule is already present in the system. So that is why we call it as a rule based reasoning. So I don't expect that you will draw this diagram, but at least for a while, just see what is the component. So we have the three level: data level, control level, and knowledge level. So at the data level, we have the working memory. तीन components है: working memory, inference engine, and the knowledge level. So the knowledge level is, you can call it as the knowledge level. Inference engine is the control level. Then we have data level where we have the working memory. And then this arrows and flow, you have to draw it properly if this question is asked, because that is what is important, because it shows कौन कैसे कर रहा है. जैसे inference engine से working memory में create new data elements, then modified attributes of the data element, remove the data element. The knowledge level say it will decide something, and who has to act? Working memory. Then working memory will recognize that particular fault and he will update it in the knowledge level. At the knowledge level, I will match the rules. सारे rules इधर suppose है. Then I will select the best rule based on my current fault, and then some action will be invoked. Okay, so then the interference engine will work. So the arrows are important. So यहाँ पे दो upward है, यहाँ downward है. Okay, so यहाँ पे दो upward and this is going downward. So whatever base you want, you can remember it. So now let us see the explanation of this particular diagram. So we have the knowledge base. Okay, at the knowledge level, we have the knowledge base. So here is an expert, we can say. So all the problems in the network, जो हो सकता है, possible problems in the network. Okay, so all that definitions are stored at this knowledge level. So if a particular action that I have to take based on a particular problem, okay, that is present at the knowledge level. So here it is said, so what the knowledge level consists of, the definition of the problems in the network. So it's like a library. मुझे जितने सारे problems पता है, उतने सारे problems I will store it, and some actions also will be written in the or mentioned at the knowledge level. So the knowledge based information is something rule based. This is what I was trying to tell you. एक rule है कि if ये हुआ, then I will do this. Okay, so this is what is actually rule based. If ये हुआ, then I will do this. Or this is the condition. My network is in this condition, then I will take so and so action. So that rule is already mentioned over here. Okay, so knowledge level में सारे network problems stated है, all possible. See, it is not कि 100% ही सारे problems होंगे. All maximum possible problems are stated, and also कि they will provide a solution. Only what I need to do is, seeing my current state, what I will do is I will check with the knowledge level and I will try to see कि मेरा जो अभी का problem है ये है. Okay, see, might not be exact problem in words and everything, phrases will be there, but I can correlate. हाँ, मेरा problem शायद ये है, तो शायद मुझे ऐसा करना चाहिए. So that's why we have an inference engine also, because I might not have the exact kind of problems stored in the database. That is the knowledge level. So then inference engine will try to find, here you can see match potential rules. Okay, so it will try to find out कि हाँ मेरा ये problem है, ये इससे match हो रहा है. Okay, then I will select the best rule, and then what the inference engine will give to the working memory. So it will modify the attributes of the data element. So he will take some action to solve that particular problem. So rule contains rule. So knowledge level, it contains rule that indicates which operations are to be performed when. Okay, so here you can see at the knowledge level, the rules are all indicated. The working memory, so now talking about the working memory. So the working memory, it contains all the information of the working state of the network. So the current state of the network, the entire topological scenario, क्या-क्या चीजें हो रहा है मेरे network में, everything will be mentioned in the working memory. Okay, so if my network has gone, here what is written in the faulty state, okay, something has happened, okay, an alarm is generated or an fault is indicated, so it will be indicated in the working memory. So pehla fault indication mere working memory pe aayega, because all the current scenario is present in the working memory. Then what the inference engine will do along with this knowledge level, ये जो वर्किंग मेमोरी में उसको पता है कि अभी ये चीजें सारी हो रही है, गड़बड़ सारी इधर हो रही है. So the inference engine will then check the knowledge level and it will try to find out the best match. Okay, once it find out the best match, then what it will do, he will draw some conclusion. So then the knowledge base executes an action on the working memory. So inference engine ने सारा कुछ बता दिया है, match कर दिया है, then the knowledge level will tell the working memory to act. To act means do something to solve your particular problem. So this is your rule-based reasoning. I will quickly finish this. Has Frida ma'am joined? No, she has not joined. Okay. The second one is a model-based reasoning. Okay. So what we do in a model is, I'll just explain in simple word. मेरे पास एक network है. I'll just show you this diagram. मेरे पास एक normal physical network है जहाँ पे मेरे पास ये NMS है, एक backbone network है. Then in a network, you know, very simple network is taken, a router, and then hubs are there, hub 1, hub 2, hub 3. Okay, now what I do is, I want to use event correlation technique, and my aim is finally to diagnose the fault. That is what we are trying to do. So instead of working with the entire network, what this model-based reasoning will do is, ये router क्या कर रहा है, hub से data ले रहा है, and it is from the backbone network, the data is transmitted to the NMS for taking some decision. Okay, similarly, from hub 2, the data goes to this router, and whatever alarms or notifications or koi fault indicate ho raha hai, then the router it gives to the NMS. So what happens every time, whatever the fault that comes, the router is routing to the NMS to take some decision. Now what I want to do is, I want to find out the fault. So what I do is, now just see such a big thing. यहाँ से fault हो रहा था, ये यहाँ पे जा रहा था, to find out a particular solution. Now what I do is, I create a model for the router, and I create a model for each individual hub. Now what do you mean by this router model? यहाँ पे भी router है, अभी यहाँ का router model. Now see what this router model will do is, it will check the functioning of the router itself. Okay, so if I am Poonam, I am trying to find out fault with Poonam only. Okay, so if I see कि no, my students are not paying attention, whatever I am teaching, they are not listening, they are not performing well, means first I will feel that there is problem with me only. Then suppose I realize नहीं, मैंने तो ये इनको पढ़ाया था, मैंने तो इनको सब बोला था, तो कहाँ पे प्रॉब्लम है? कहाँ पे प्रॉब्लम हो सकता है? पहला स्टूडेंट जो है वो स्टूडेंट में प्रॉब्लम है. I hope you are getting the analogy. Now suppose this hub is a student, so there is a model of the student. So what the student will do is, suppose the student has failed in a subject, so he will directly not blame the router. तुमने मुझे नहीं पढ़ाया है, टीचर ने मुझे नहीं पढ़ाया, टीचर ने मुझे नहीं बताया. The hub model will check itself. Here that checking is pinging. The hub network will ping itself to find out whether I am connected to the router or not. वो 3 बार अपने आप को पिंग करेगा. 3 बार सपोज अपने आप को पिंग किया, उसको कोई कनेक्टिविटी नहीं मिला, then he will feel either there is a problem in my port or there is a problem in the router port. This could be one of the reason. Now what this hub will do is, ये बच्चे को कुछ समझ में नहीं आया, okay, either उसको समझ में नहीं आया या टीचर पढ़ा नहीं पाया. So instead of directly telling the teacher, ma'am, I did not understand, what he will do, he will slowly WhatsApp it to the second student. Did you understand the concept which ma'am was teaching? तो ये बच्चा शायद बोलेगा हाँ कुछ तो समझ में आया. So then the hub 1 will feel, अरे बाबा इसको कुछ तो समझ में आया. Now suppose hub 2 says, the second student says, हाँ मुझे सब समझ में आया. So then the hub 1 will realize कि okay, there might be problem at my end. I was not able to hear the voice of the teacher because there might be connectivity issue at my end. So what this hub model is doing is, he is checking first internally and then he is trying to correlate with his PAR members. Once he is satisfied कि नहीं ये लोगों को तो सब connectivity issue, everything is proper, means there is something wrong at my end with the router, then only he will raise an alarm and send that message to that router. Now this router model, what he will do is, internally it will check its own function. जैसे मैंने बोला, I being a teacher, I might check what has happened at my end. Now if the router feels that no problem is there at the router end, so then the conclusion is there is a problem at the hub end. Hub के कोई port में शायद problem होगा. Okay, so this way they created a model of router, they created a model of hub. So internally they will check themselves before raising an alarm. So this is what the model-based reasoning tells you. So in the book there has been a nice example that is given. Okay, so what is that example is, suppose we have a classroom. In the classroom there are students and there is one teacher, and outside the classroom there is what is the model is, I have students sitting inside the classroom and there is a teacher. Okay, so and outside the classroom I have a computer network with router and workstation. So what is the model is, the teacher is the model of the router and the student is the model of the workstation which is present. Okay, so this is the model which we are creating. So how the communication is doing, तुम लोग class में बैठ के you are communicating with your real world counterpart, that is the workstation outside the classroom. Okay, and I am the teacher, I am communicating with the router which is again outside the classroom. Okay, so now suppose one student feels he is not able to access his workstation which is outside the classroom. So what he will do is, he will check internally first, ping करके देखेगा कि no, I am not able to connect to the workstation. So instead of directly approaching the computer network or router outside, what this student will do is, he will ask the teacher, teacher, whether you are able to communicate with your router outside. Okay, तुम लोग का suppose, just imagine the situation, you are sitting in the classroom with the teacher, okay, and you are working on the workstation which is present outside. If you are not getting connectivity, will you walk down outside the class where everybody is sitting and try to find out where the problem is? It will look so bad also in normal situation. So what you will do, you will inform or you will tell the class teacher, ma'am, are you able to communicate with your router, जो teacher का model है? If the teacher says or teacher sees कि हाँ, yes, I am able to communicate with my router, means ये मेरे end में कोई problem नहीं है, then based on whether the teacher says yes or no, that student model will feel or can find out कि okay, either there is a problem with his input output port or the port of his counter workstation. So this is one example of scenario of classroom where a model based reasoning is used. And as I said, ये model based reasoning is used by the company called as Cabletron Spectrum. You note down the name. Okay, so it was a giant system who was the manufacturer of all the computer equipments, and all the prices of all the computers and all the related accessories went down due to their coming in the market in the year 1990. Okay, so pehle sare bahut costly hua karte the. Then this Cabletron Spectrum. So in Cabletron Spectrum, for fault management, they are using the model-based reasoning. So I will be stopping here today. At least you understood what I am trying to say. Yes or no? Yes or no?
Yes, ma'am.
Yes, ma'am. Okay. Okay, attend your roll call. Number 1.
Present, ma'am.
2,
Present, ma'am.
3, 4, 5,
Present, ma'am.
6,
Present, ma'am.
7,
Present, ma'am.
8, 9. 9 is not a 10,
Present, ma'am.
11,
Present, ma'am.
12,
Present, ma'am.
11 is there. 13, 14,
Present, ma'am.
15, 16,
Present, ma'am.
17,
Present, ma'am.
18,
Present,
19,
19 present, ma'am.
20,
Present, ma'am.
21, 21, 22,
Present, ma'am.
23,
Present, ma'am.
24, 25,
Present, ma'am.
26, 27, 28,
Present, ma'am.
29,
Present, ma'am.
30,
Present, ma'am.
31,
Present, ma'am.
32,
Present, ma'am.
33,
Present, ma'am.
34,
Present, ma'am.
35,
Present, ma'am.
36, 37, 38, 39, 40,
Present, ma'am.
41, 42, 43,
Present, ma'am.
44, 45,
Present, ma'am.
46,
Present, ma'am.
47, 49, 50, 51,
Present, ma'am. 51.
Abhiram, 53,
Present, ma'am.
54, 55,
Present, ma'am.
56,
Present, ma'am.
57,
Present, ma'am.
58,
Present, ma'am.
9,
Present, ma'am.
61,
Present, ma'am.
62,
Present, ma'am.
63, 64, 64,
Present,
65,
ma'am.
Abhishek,
65 present, ma'am.
66,
Present, ma'am.
67,
Present, ma'am.
68, 69, 70, 71,
Present, ma'am.
72, 73,
Present, ma'am.
74,
Present, ma'am.
5,
Present, ma'am.
76,
Present, ma'am.
77,
Present,
70,
ma'am.
78, 79,
Present, ma'am.
80, 81,
Present, ma'am.
82, 83,
Present, ma'am.
84,
Present, ma'am.
85 is there, 86, Aniket, 87,
Present, ma'am.
88, 89,
Present, ma'am.
92. Okay, so that's all. Is Frida ma'am there? Your next lecture is at 3 o'clock. So you can take a break. Frida ma'am will join.